All right, the next type of solving we're going to do is called literal equations. Basically, what this is it gives you an equation, one you're probably familiar with, so you might recognize these two. One on the left is the formula for area of a trapezoid. One on the right is the formula for surface area of a cylinder. So basically, it gives you one of these, and instead of it being A equals, they want you to solve for a different letter, all right? And they'll tell you which one they want. So for instance, on this first one, they want us to solve the above equation for B2. So they want B2 to be by itself at the end of this problem once we're done. Okay, so let's see if we can make that happen. All right, I'm just going to rewrite it down here. All right, so trying to get B2 by itself. So I want all this other stuff to move to the other side. Okay, so you kind of want to avoid a few pitfalls here. Like our first instinct when we see parentheses like this is, oh, distribute. Don't want to do that. That's going to be adding more stuff to get rid of later. Okay, so let's not do that. Let's just start getting rid of some stuff. We'll start outside the parentheses and then we'll work our way closer to B2 as we go. So let's start with this 1/2. Okay, it's being multiplied by h. So normally when something's being multiplied, we divide. Okay, but that looks weird. If you put divided by a half, I don't like that. So instead of dividing by a half, let's multiply by its reciprocal. The reciprocal of 1/2 is flipped over, 2/1. So to get rid of a half, we multiply the whole thing by 2. Okay, we do that over here as well. All right, so this is what that's going to look like. 2a equals h times b1 plus b2. Okay, again, still don't want to distribute. That's going to be adding more stuff in there that we'll have to get rid of. We don't want to have to do that. Okay, so h is being multiplied by the parentheses. So this time, since it's not a fraction, we can just divide by h. Okay, so we've got 2a over h equals b1 plus b2. No need for the parentheses anymore because there's nothing outside to multiply by them. All right, well, one last step, we need to get rid of this b1. It's a positive b1, so we need to subtract b1. So you get 2a over h minus b1 equals b2. And that's your final answer. All right, you may see these combined together. We could get a common denominator and then combine it all into one fraction, but that's not really necessary. Once you get the variable they asked for by itself, you're done. All right, so why don't y'all give the second one a try on your own, see how you do, all right, and then come back and unpause it and see if you got it right. All right, so this one, we want to get h by itself. So there's h right there. All right, so scan the problem. Make sure there are no other h's. Sometimes there are like multiple of whatever variable, and you have to do some factoring stuff. This one, that's the only h. So look at this whole term right here. All right, there's nothing, no h. So I just want to move this entire term to the other side. All right, that's going to be my first step. So since it's a positive 2 pi r squared, I'm going to subtract 2 pi r squared. And do that over here as well. So that'll leave me with s minus 2 pi r squared equals 2 pi rh. All right, well, now I need to get rid of all this 2 pi r, so I have h by itself. Now, luckily enough, everything's being multiplied. 2 times pi times r times h. So to get rid of all those, I just divide, the opposite of multiply. Divided by 2 pi r. And this whole thing over here gets divided by 2 pi r. So I'm left with h equals, all right, now here's the tricky part because people like to start simplifying stuff and you're not always allowed to. So it looks like we should be able to cross out the 2's and cross out the pi's and cross out the r's. Cannot do that. Okay, the reason is there's also this s over here. So if I started crossing stuff out here, I would also need to be able to cross stuff out from this term. Okay, all terms have to have the same common factor to be able to cross them out. S doesn't have a 2 or a pi or an r, so we can't do anything. This is it. That's as simple as we can make it. All right, got one more for you. All right, you may recognize this formula from your algebra classes. This is the slope formula. Okay, it wants to solve for y. All right, so scan the problem. There is only one y. This is a y1. The 1 makes it a different variable from just the plain old y. Okay, so we just need to get this y by itself. All right, notice we're in a big fraction here. So first thing I want to do, let's cancel out the fraction. Let's multiply by x minus x1. Okay, that means I have to do the same thing over here. So this is m times x minus x1 equals y minus y1. All right, now, so this was the slope formula, right? Let's write that down. We're going to be doing some linear function stuff very soon, so a little refresher course on this won't hurt. You may recognize this. This step actually has its own name. This is called point slope form of a line. All right, then we have one more step to do, and that is to add y1 to both sides. And we get m times x minus x1 plus y1 equals y. Now, if we had numbers in there instead of these y1s and x1s, we'd be able to like distribute the m and then combine some like terms, and then it would be slope-intercept form. Okay, I'm not going to write that down because that would involve a lot more stuff that we don't need to go over right now. But I did want you to see how all these formulas for slope of a line are connected. All right, and we can investigate that while doing our little rule equations that we've been working on.